In this video, we will learn about some 802.11 topologies and a few basic terminologies that you should know about Wi-Fi. So let's discuss about the 802.11 topologies. This is going to be a short video, not a big one. So yeah, one is simplex topology. A lot of these topologies are kind of misunderstood, so I'll try to clear the air here. Simplex topology, or I should say in simplex communication, one device is capable of only transmitting and the other device is capable of only receiving. Okay. Only one can transmit and only one can receive. They are capable of only that. Example is an FM radio. Okay. Second is half duplex. In half duplex, both the devices are capable of transmitting and receiving. However, only one device can transmit at a time. Okay. Both devices can transmit and receive. However, only one can at a time. Example is a walkie-talkie and our 802.11 communications. Wi-Fi is a half duplex medium, right? We have heard about this before as well. Cool. The third type of topology is a full duplex topology. Okay. In a full duplex communication, both devices are capable of transmitting and receiving at the same time, and they can do that as well. It's like a telephone conversation, right? Both the devices are capable of transmitting and receiving at the same time. What is the example of this? A telephone conversation, right? On a telephone, we both can talk and receive at the same time. Telephone conversation. Also, 802.3 communication, that's the wired side communication. So these three topologies are mostly misunderstood. Wi-Fi works on half duplex. Each radio on the Wi-Fi, that is the client radio or the access point radio, they have to contend for their for their turn to send traffic. They cannot just come up and start sending traffic. They have to wait and contend for the medium. And once they win the contention, that's when they can send traffic. So we will anyway go in depth about how contention works and what all parameters it takes into consideration before a radio can win a contention mechanism and then start sending traffic. We'll talk about that in a different chapter. But this is something which you should know: a simplex topology, a half duplex topology, and a full duplex topology, and how things work in that. Cool. So some basic terminologies. The first one that you should know is a very common one, but most people misunderstand that. What is an access point? We will try to understand this in the simplest way possible. An access point is just a hub with an antenna and a radio card. That's it. If anyone asks you what is an access point, it is just a hub with a radio card and an antenna. They are half duplex devices, of course. They are half duplex devices because RF medium is used, RF medium uses half duplex communication that only allows for one radio to transmit data at a time. So any hub with an antenna and a radio card will make an access point, and they will work on half duplex. That's it. That's exactly what an access point is for you. Second is, what is a client station? I remember this question of what is an access point being asked by me in one of the interviews, and I got the someone gave me an answer. It was a he talked about it like for 10 minutes about what is an access point, but the answer was incorrect. The answer is simply this. Try to put this in as simple way as possible, and and don't forget it's a half duplex device. It works only on half duplex. It doesn't work on full duplex. Anyway, what's a client station? A radio card that is not used in an access point is typically referred to as a client station. That's it. A radio card that is not used in access point is called a client station. Again, these devices are also half duplex. They also have to contend for the medium to send traffic. Okay, remember that. Now, the third terminology is integration service. Now, this is important because in a lot of places this is not explained pretty well. So I'll try to explain this in very simple English and very simple language. Now we know that a wireless client connects to an access point, which in turn connects to a switch and then a router and then out, for example, out to the internet. This is a standard communication happening. Now, my client, which is a Wi-Fi client, will understand 802.11 frames. It is talking on Wi-Fi. Wi-Fi is 802.11, but my switch here will only understand 802.3 frames. It doesn't understand Wi-Fi frames. So there has to be a device in between which will convert dot 11 to dot 3 and vice versa. Dot 3, 802.3, sorry, I'll just correct that, to 802.11 frames. Someone needs to do this for a network to work properly. Now, the device that does this is called an integration service. In this topology above, a client sends a .11 frame. AP understands that, but AP also knows that the connecting device for me is a switch here. So I cannot send the .11 frames out to the switch. So the AP in this topology will convert the frames from dot 11 to dot 3 and send out to the switch here. Similarly, the reverse traffic that's coming from the switch, AP receives a dot 3 frame and converts that into dot 11 like this and then sends it out to the client for it to understand. AP is acting as the integration service. So any device that converts, that does this change is called an IS. Now, in another topology, let's say I have a client here and which is connecting to an access point. This access point is connected to a switch and this switch is connected to a WLAN controller. And then, it's kind of like a router and then out to the internet. In this topology, access points are dumb devices which are managed by the controller. In this, access point was independent. They didn't need a controller. Here, an access point needs a controller to work. In this topology, the IS will be a WLAN controller. An IS will do the job of conversion of frames. A controller will do this job in this topology. So any network in which an access point is handled by a controller will change the dot 11 frames into dot 3 and dot 3 frames into dot 11 for things to work. Remember this. This is very important because we missed the trick here. Okay, so remember this. Anyway, moving on to some other terminologies. The next one is SSID. What's an SSID? It's a service set identifier. We all know what an SSID is. We have SSIDs broadcasted in our house also, in our home APs. It's a logical name to identify a wireless network. Simple. It's a logical name to identify a wireless network. Okay. It can be up to, the name can be given up to 32 characters. It cannot go beyond 32. It has to be within 32. Okay. That's what an SSID is. So if you go home and then you click on the Wi-Fi network that you want to connect on, that's called an SSID. That network name is called the SSID. Okay. The next is basic, hang on, basic service set, BSS. BSS is kind of like a topology. Okay. The communicating devices that make up a BSS are solely one AP with one client or more clients. So any place where you see an access point connected to an connected to a client or more clients, client one, client two, client three, they will constitute a BSS together. This is kind of like a topology. Okay. So you need to understand that BSS, and the next terminology is a basic service set identifier, that is BSSID. I'm sure we've heard about this as well, but there is a possibility that it is not clear as to what this really is. We know that BSS is the 48-bit MAC address of the access point radio. Okay, this is in a way correct, but the actual definition of a BSSID is it's a layer 2 network identifier for me, identifier of an individual BSS. If you have one SSID broadcasting on a AP on an AP radio, then the BSSID for that SSID is the MAC address of the access point radio. Absolutely right. But if you have more SSIDs broadcasting, then the BSSID will change. It will be individual to that BSS. Okay. So the right definition is BSSID is a layer 2 network identifier. That is the proper definition of a BSSID, not just the MAC address of an access point radio. Because this may not be true if you have more SSIDs configured on the AP radio. If you have one, this is it. It's the MAC address of the access point radio. But with more SSIDs, you'll have different BSSIDs. Okay, hope that makes sense. The next thing is basic service area, which is BSA. Now, BSA is the physical coverage area provided by an access point in a BSS. I have an access point. My coverage pattern or my coverage reaches till this area. Now, this is my BSA for this access point. Okay. For access point number one, this is the BSA where my coverage, my physical coverage can reach. That is my BSA of a BSS. Now, clients can move anywhere in this BSA while maintaining connectivity to the access point without a problem, right? So these are some few terminologies that you should know because these terms are going to be used quite often as we move forward in the following chapters, especially when you talk about BSSID, BSA, BSS, these things we should know by heart. Whenever we talk to somebody about Wi-Fi, these are some basic terminologies that we should be clear about. Cool. So we'll anyway meet in the next video now. Thank you so much.